In this lecture, I would like to discuss about the structure of diborane, that is B2H6. Bonding and structure of diborane is very interesting one. Diborane is an electron deficient molecule. Therefore, its structure and bonding is not normal. It involves abnormal bonding. It is expected that in diborane molecule, there should be 7 covalent bonds as like of ethane molecule. In ethane molecule, there are total 14 electrons, but in diborane molecule, there are total 12 electrons. There are total 12 electrons. Let us show this. In diborane, there are 2 boron atoms. So, boron, which is having the atomic number 5. So, it is having the electronic configuration boron. So, you can see 1s2, 2s2, 2p1. So, in the valence shell, there are 3 electrons. So, for 2 boron atoms, so number of valence electrons 2 into 3, it is equal to 6. And there are 6 hydrogen atoms. So, one hydrogen atom carry 1 electron. So, it is 6 into 1. So, it is equal to 6. So, total number of the electrons are equal to 12. So, actually, to form a molecule and to show the bonding as like of this, so it is expected that there should be formation of the 7 covalent bonds between the boron and hydrogen atom. But to form the 7 covalent bonds between the boron and hydrogen atom, you can see here 1, 2, 3, 4, 5, 6, 7. So, for 7 covalent bonds, the number of the electrons which require, it is equal to 14 electrons. But actually boron molecule is having only 12 electrons. So such type of the normal bonding is not involved in the diborane molecule. That's why diborane molecule is called as an electron deficient molecule. What is the electron deficient molecule? The molecules which has less number of the electrons available for the bonding, than requirement, that molecule is generally called as a electron deficient molecule. So let us going to discuss the structure and bonding of diborane molecule. Electron diffraction data suggested that the diborane molecule has a bridge structure. As like of this, now we cannot represent the structure of the diborane molecule. So it is having the bridge structure. There is a formation of bridge, boron, hydrogen, boron. Bridge formation is there. So in this structure, the 2 hydrogen atoms, these are the terminal hydrogen atoms. These are the terminal hydrogen atoms, and these 2 hydrogen atoms are the bridge hydrogen atoms. So in the figure, it is shown that there are 4 terminal hydrogen atoms attached to the 2 boron atoms. You can see here 4 terminal hydrogen atoms, 1, 2, 3, 4, attached to the 2 boron atoms. The remaining 2 hydrogen atoms are involved in the formation of the boron hydrogen boron bond or bridge. Hence, they are called bridge hydrogen atoms. Actually, these hydrogen atoms are perpendicular to the plane of the molecule. and also prevent the rotation between the two boron atoms. Also prevent the rotation between the two boron atoms. Now, the structure of the diborane molecule can be justified by the manner in which diborane undergoes methylation. When diborane molecule undergoes methylation, okay, let us show this. Methylation of diborane molecule. The structure of the diborane can be shown on the basis of uh, methylation of the diborane molecule. So let us draw here the structure of the diborane molecule. Okay, 4 hydrogen atoms are the terminal hydrogen atoms, and 2 hydrogen atoms are the bridge hydrogen atoms. 2 hydrogen atoms are the bridge hydrogen atoms. There is a formation of the boron hydrogen boron bridge. So on methylation, this diborane molecule undergoes replacement of the hydrogen. So first of all, 4 hydrogen atoms are replaced by the methyl group, 4-methyl group. So there is a formation of this structure. Okay, replacement of 4 hydrogen atoms here. The terminal hydrogen atoms are replaced, and the bridge hydrogen atoms are remains as it. So you can see the structure here. Okay, the terminal hydrogen atoms are only replaced here, and the bridge hydrogen atoms are remaining. Now on further methylation of this structure, these 2 hydrogen atoms are also replaced, means rupture of the structure, rupture of the bond, and there is a formation of 2 units such boron CH3 thrice plus boron CH3 thrice. So it indicates that in the diborane molecule there is the presence of the boron hydrogen boron bridge. Presence of the boron hydrogen boron bridge. Okay. So the formation of boron hydrogen boron bridge can be explained on the basis of hybridization. So let us see the central boron atom or boron atom in the diborane molecule undergoes what type of the hybridization. So this is the electronic configuration of the boron. Now the ground state electronic configuration, it is 2s2 2p1. In the excited state, this electron is promoted here. So there is a 3 half-filled orbitals and 1 empty orbital. So all the orbitals get mixed up and the boron atom shows sp3 hybridization. Remember that these 3 orbitals are half-filled orbitals and 1 orbital is empty. So there are 4 sp3 hybrid orbitals are formed here. There are 4 sp3 hybrid orbitals are formed here. Each boron atom undergoes hybridization, formation of 4 sp3 hybrid orbitals. Okay, it means that each boron atom has 4 sp3 hybrid orbitals. Now in these 4 hybrid orbitals, 3 orbitals have an electron, 1 2 3. 3 orbitals have an electron and the 4th orbital is empty. 2 of the hybrid orbitals of the boron with an electron undergoes overlapping with 1s orbital of the 2 terminal hydrogen atoms. Okay, this going to combine with or overlapping with terminal hydrogen atoms. It is going to overlap with terminal hydrogen atom. Okay, so this is for the one boron atom, same for the another boron atom. Okay, now this leaves two hybrid orbitals with boron, of which one has an electron and other is empty. Okay, now the two hybrid orbitals are remaining, one is having the electron and other is empty. So there are two such boron hydrogen boron units in diborane are formed. Let us show this. Okay, bridge formation is takes place there. So diagrammatically I would like to show this first. You can see the diagram here, how the overlapping between the sp3 hybrid orbitals with atomic orbital of the hydrogen is takes place. Suppose now boron is having 4 sp3 hybrid orbital. This is one, this is second one, this is third sp3 hybrid orbital. As boron undergoes sp3 hybridization, it means that it is having 4 sp3 hybrid orbitals. Out of these 4 sp3 hybrid orbitals, 3 are having the electrons. Suppose that 3 orbitals are having the electrons here. So these are the 4 sp3 hybrid orbitals. Okay, sp3, then sp3 hybrid orbital. Similarly here sp3 hybrid orbital empty. Now this is sp3 hybrid orbital is empty, and this is sp3 hybrid orbital. Then the another boron atom is also having the same 4 sp3 hybrid orbitals. So let us show this 4 sp3 hybrid orbitals. Okay, so same situation will be here. It is having 3 up-filled orbitals are there and one is empty. Now out of the 4 sp3 hybrid orbital, first of all the 2 sp3 hybrid orbital overlaps with terminal hydrogen atoms, atomic orbital of terminal hydrogen atom, that is 1s orbital. So this is the hydrogen atom. Similarly here 2 sp3 hybrid orbital get overlap with 1s atomic orbital of the terminal hydrogen atom. Same will be here, overlaps with 1s atomic orbital, that is sp3 overlap with s orbital. Same will be here. Okay, overlaps with this s orbital, sp3 s overlap. Now 2 hydrogen atoms are remaining, so there is a formation of the bridge here. Okay, this is 1s atomic orbital of the hydrogen atom, and now there are 2 electrons, because hydrogen atom carry 1 electron and already this sp3 hybrid orbital is having the electron here. So 2 electrons now, but atoms are 3. 2 electrons and atoms are 3: boron, hydrogen, boron. Same will be here. sp3 hybrid orbital get overlap with 1s atomic orbital of the hydrogen atom. Okay, 1s atomic orbital of the hydrogen atom here, and this is sp3 hybrid orbital. So thus in this way there is a formation of the bridge. The bridge formation is takes place here. So in the bridge formation, the filled sp3 hybrid orbital of the boron get overlap with 1s atomic orbital of the hydrogen atom and empty sp3 hybrid orbital of the another boron atom. Okay, empty sp3 hybrid orbital of the another boron atom, and same will be here. Thus there is a formation of the 2 boron hydrogen boron bridge. Now this type of the bonding is called as, actually 3 atoms are there, but only 2 electrons are involved here. So this type of the bonding, it is called as 2 electron 3 center bonding. This is abnormal bonding. Actually bonding is 2 electron 2 center bonding. In the molecule, such type of the bonding is present. For example, hydrogen molecule. In hydrogen molecule there is a 1 covalent bond, so 2 electron and 2 center bonding. But now in this case, in the boron hydrogen boron, 2 electrons get delocalized on the 3 atoms. Okay, So these two electrons bind the three atoms, two boron atom and one hydrogen atom, and there is a formation of the bridge. So same thing will be here. So this type of the bonding, it is called as two electron three center bonding. So we explain this bonding on the basis of the valence bond theory. Okay. So bridge formation involves overlapping of hybrid orbital with an electron of one boron atom on one side and empty orbital of another boron atom. This is empty orbital and this is supposed to be filled orbital. Okay. So and 1s orbital of the central hydrogen atom. Suppose that this is 1s, this is sp3 with electron, and this is sp3 of the another boron atom, but it is empty. Okay, this is a situation where three orbitals overlap. Okay, as we already shown this with each other, but only two electrons are available for the bonding. You can see here only two electrons are available. It is two electron three center bonding. Okay, therefore this type of the bonding, it is called as two electron three center bonding. Therefore boron hydrogen boron bridge involves two electron three center bond. Okay, and its shape is also banana type. Boron hydrogen boron, shape of the orbital, it is banana type shape. Okay, so let us see here. There are two such boron hydrogen boron bridges involving two electron three centered bond. So already I have shown this structure to you. Okay, so these are the three sp3 hybrid orbital. Okay, three sp3 hybrid orbital here you can see, and this is empty. This is supposed to be empty orbital. Okay, this is also empty orbital here, and formation of the boron hydrogen boron base. Okay, so from the above discussion it is clear that in diborane molecule there are four terminal hydrogen atoms. So this bonding is two electron two center bonding. This boron hydrogen bond, this is two electron two center bonding. Okay, so it means that four terminal hydrogen atoms are there. This is 1 2 3 4. So 4 into 2, 2 electrons are there. So total electrons are 8 here. Now there are two bridges, boron hydrogen boron. So this is two electron three center bonding. So two such bridges are there. So 2 into 2, 4 electrons. So total electrons are equal to 12. So we know that there are 12 electrons are present in the diborane molecule. So in this way we explain this bridge formation on the basis of the hybridization, on the basis of the valence bond theory. Let us going to represent this on the basis of the molecular orbital theory. Okay, on the basis of molecular orbital theory. So let us explain this on the basis of the molecular orbital theory. Okay, so first of all let us explain. See here, molecular orbital diagram for boron hydrogen boron bridge, and we know that how the molecular orbitals are formed. Molecular orbitals are formed by the overlapping of the atomic orbitals. When one atomic orbital get overlap with another atomic orbital, due to the overlapping there is a formation of one bonding and one anti-bonding orbital. So now the MO diagram for boron hydrogen boron, one unit it is shown here. Okay, so MO diagram of boron hydrogen boron unit involve overlaps between two boron atoms atomic orbitals. Okay, two boron atomic orbitals. So let us see here, two sp3 hybrid orbitals onto the left hand side, two sp3 hybrid orbitals onto the left hand side, and one s atomic orbital of the hydrogen atom. Okay, so these are the two sp3 hybrid orbital of the boron atom, two boron atoms. Okay, and this is the 1s atomic orbital of the hydrogen atom. Now there is a overlapping between this. Okay, so first of all, one of the sp3 hybrid orbital get combined here with 1s atomic orbital of the hydrogen atom. So there is a formation of the psi b bonding molecular orbital and psi a antibonding molecular orbital. Okay, let us, I would like to draw this diagram on the another screen. So you have to just see now here. Okay, see the molecular orbital diagram of boron hydrogen boron bridge. Okay, boron hydrogen boron bridge. So let us show this. That is 2 electron 3 center bonding. Already we have explained this. 2 electron 3 center bonding. So MO diagram of boron hydrogen boron bridge. 2 boron atoms and 1 hydrogen atom. So on to the left hand side, let us represent the atomic orbitals of 2 boron atoms, which are that sp3 hybrid orbitals. So there are 2 sp3 hybrid orbitals. There are 2 sp3 hybrid orbitals. Okay. So this is sp3 hybrid orbital. This is also sp3 hybrid orbital. This is for 2 boron atoms. Okay. And on to the right hand side, let us represent the atomic orbital of the hydrogen atom, that is 1s atomic orbital. Okay, which is having 1 electron here. 1s atomic orbital of the hydrogen atom. So atomic orbitals of hydrogen atom. Okay, and in the middle part, let us represent molecular orbitals of boron hydrogen boron bridge. Let us explain first this, how there is a formation of the molecular orbitals here. Now one boron sp3 hybrid orbital, it is now 1 electron, other is empty here, so 1 electron. Okay, now the overlapping between these two will be takes place here. First of all, one of the sp3 hybrid orbital get overlap with 1s atomic orbital of the hydrogen atom, formation of psi b bonding molecular orbital, and antibonding molecular orbital, it is psi star b. Okay, antibonding molecular orbital, it is psi star b, antibonding molecular orbital is formed here. So let us represent this psi star b antibonding, or we can write only 1 minute, psi a antibonding molecular orbital. A stands for antibonding. Okay, this is psi a. Okay, see here. Now this is one bonding molecular orbital, this is antibonding molecular orbital. So 2 electrons will be goes into the bonding molecular orbital. This is 2 electron 3 center bonding, 3 atoms are there and only 2 electrons are there. Now one orbital it is remaining here, so that is remains as non-bonding. Okay, that is remains as non-bonding. So let us represent here psi non-bonding orbital. So thus in the VHB unit, there is a formation of the 3 molecular orbitals, 1 bonding, 1 non-bonding and 1 anti-bonding. Okay, 1 bonding, 1 non-bonding and 1 anti-bonding. So let us show this here. Okay, overlapping between 1 sp3 hybrid orbital of each boron atom and 1s atomic orbital of the hydrogen atom gives 3 molecular orbitals, bonding, non-bonding and anti-bonding. Okay, so for each boron hydrogen boron bond and 2 electrons enter, here 2 electrons are there, they are entered into the bonding molecular orbital, which is having the lowest energy level. These bonding molecular orbitals are having the lowest energy level. Now these are their corresponding equations. So let us see first for psi b bonding molecular orbital. So it is equal to 1 by 2 into psi b1, means b1 means boron, psi 1 for boron atom 1 plus 1 by 2 psi boron atom 2 plus 1 upon root 2 into psi h. These equations can be written there. So where these are 1 by 2, 1 by 2 and 1 upon root 2 are their coefficients. This is for bonding molecular orbital. Everywhere there is a positive sign. In antibonding molecular orbital, now minus sign is there, remaining will be same. 1 by 2 psi b1 plus 1 by 2 psi b2 minus 1 upon root 2 psi h. And in non-bonding molecular orbital, there should be only boron atom is particularly there. So 1 upon root 2 psi b1 minus 1 upon root 2 psi b2. So we have to remember these equations. The equation for non-bonding becomes this. The equation for bonding becomes this. Everywhere there is a positive sign. And here it is anti-bonding, therefore it is a negative sign here. Thus, each boron hydrogen boron unit now forms a three-centered system and held by two electron, called two electron three center bonding is there. Okay, this is two electron three centered bonding. Okay, so since the bonding electron pair operates over the three centers, three atoms are there, and therefore the bond order is 1 by 2, because one bond it is onto the three centers. Okay, so bond order it is half to that of, and the bonds have the nearly half the strength of the normal two centered two electron bonding. Okay, two centered two electron bonding is there. Okay, so let us going to discuss the molecular orbital diagram of the diborane now. Molecular orbital diagram of the diborane. So onto the left hand side, the atomic sp3 hybrid orbitals of the boron are taken here. Onto the right hand side, the 1s atomic orbital of the 6 hydrogen atoms are taken here. Okay, and the middle part it is the molecular orbital diagram. Okay, so onto the left hand side you can see here number of hybrid orbitals are there, 1 2 3 4, 1 2 3 4. Four hybrid orbitals are there, as they are having the identical energy, equivalent energy, so they are represented, they are having the identical energy will be here. Okay, now the 6 hydrogen atoms right side having 1s atomic orbital, so 6 electrons are there. Okay, now let us going to discuss this MO diagram. I think it is very simple one, or I would like to draw this diagram onto the other screen. You have to just see the MO diagram of the diborane molecule. Okay, MO diagram of diborane molecule B2H6. Okay, B2H6. So on to the left hand side we have to represent, we know that boron atom undergoes sp3 hybridization. sp3 means there are 4 hybrid orbitals now. So let us represent the atomic orbitals or hybrid orbitals, atomic orbitals of 2 boron atoms. And on to the right hand side we have to represent atomic orbitals of 6 hydrogen atoms. 6 hydrogen atoms. Okay, diborane molecule. So let us represent the 4 sp3 hybrid orbitals for one boron atom. So 1 2 3 and 4. Similarly for another boron atom, 1 2 3 4, we can show as like of this also. Now it is having electron here, 3 electrons, one is empty. Similarly for another boron atom, 3 electrons, one is empty. Okay, this is for 2 boron atoms. Now for hydrogen atoms there are 6 hydrogen atoms, so 6 1s atomic orbitals, 1 2 3 4 5 6. So let us represent their electrons. 1s atomic orbital carry 1 electron, so let us represent the 6 electrons now there. Okay, 6 electrons are there. Okay, so this is 1s atomic orbital. Okay, 6 1s atomic orbitals. So you can see here total number of electrons 6 plus this 6, 12. Now let us show the overlapping. First, formation of bonding molecular orbital. So we know that for each boron atom, two sp3 hybrid orbital are goes into the uh, two sp3 hybrid orbitals are involved in the formation of the sigma bond with the two hydrogen atoms. Okay, so let us show this formation of sigma bonding molecular orbital. Formation of sigma bonding molecular orbitals. So there is a formation of 4 sigma bonding molecular orbitals, or you can say this is also called as terminal bonding. Okay, so suppose that this is bonding psi b, formation of this is 4 orbitals. Okay, because there are 4 terminal hydrogen atoms, so let us present the electrons now here. 4 electrons will be here. Okay, this is terminal, formation of this psi b bonding molecular orbital 4. Then bridging. Okay, this one orbital involved into the bridging, empty and one filled. So let us show this overlapping of this formation of bridging. Okay, 2 bridging orbitals are here going to overlap with the 2 hydrogen atoms here. So this is also bonding but bridging, formation of the bridge is there. Okay, then bonding and anti-bonding. Bonding and anti-bonding. Okay, so this is psi b bonding and anti-bonding. We have to represent here anti-bonding also. 1, 2, 3, 4. This is anti-bonding. Okay, remaining now. This is bridging. Okay, let us put the electrons here also. Okay, so in the bridging hydrogen atom there are 4 electrons, 2 boron hydrogen boron bridge is there. Okay, like this. So here 2 electrons and another boron hydrogen boron bridge having the 2 electrons here. So there are 4 electrons are here by the overlapping of one sp3 hybrid orbital, one empty sp3 hybrid orbital with 1s atomic orbital of the hydrogen atom. Okay, so this is the MO diagram, and non-bonding is also there. Non-bonding orbital, it is also formed there. So let us see the diagram now here. See, okay, this is the MO diagram of the diborane molecule. Sigma terminal hydrogen atoms. Okay, and sigma bridge. Okay, bonding molecular orbital. This is sigma star bridge antibonding molecular orbital and sigma star terminal antibonding molecular orbital. Okay, sigma terminal and sigma star terminal. This energy gap will be larger here because it is pure bonding, normal bonding. Now in this case there are 3 atoms are involved in the formation of the bridge, so energy gap will be less. Okay, so now you can see here how many number of the 1, 2, 3, 4, 5, 6. Okay, so 6 bonding molecular orbitals are formed here. Out of them terminal are 4 and bridging are 2. Okay, now 2 are remaining here. So there is a formation of the non-bonding molecular orbital also. Sigma non-bonding molecular orbital also there is a formation of this. So this is the MO diagram of the diborane molecule. Very simple one. 12 electrons are there. So all the 12 electrons are into the bonding molecular orbital. Out of that 12 electrons, 8 are present into the terminal type of the bonding molecular orbital, and 4 are present into the breeze type of the bonding molecular orbital, while this is totally empty. Okay, it is totally empty there, no electrons are left to be filled here. Okay, so in this way we explain the bonding in the diborane molecule. The bonding in the diborane molecule, there are 4 terminal hydrogen atoms and 2 bridging hydrogen atoms. 2 bridging hydrogen atoms are formed there in the diborane molecule. So in this way we explain the bonding in the diborane molecule. It is quite different as compared to the other molecules. So on the basis of the molecular orbital diagram, we know that there are 4 terminal hydrogen atoms and 2 bridge hydrogen atoms are formed there. So you can see for 4 terminal hydrogen atoms, number of electrons are 8. Already we have shown in the MO diagram, 8 electrons are there, and 2 bridge, 4 electrons are there in the bridge bonding molecular orbital, and total number of the electrons are equal to 12 here. So once again you can see this diagram. Okay, overlapping between the sp3 hybrid orbital of the 2 boron atoms with atomic orbitals of the 6 hydrogen atoms. So we know that as the 6 hydrogen atoms are having the 6 electron, and it is having only 6 here for 2 boron atoms, and this one is empty. So this is the MO diagram of the diborane molecule. In this way we today explain the molecular orbital diagram of the diborane molecule.